Hi, good morning. Welcome back to school, and let's turn our camera on and kindly mute your microphone. And you may unmute when there's anything you wanted to share that would benefit the whole class. Kindly join us with our Nearpod using the code on the screen or use the link that's being shared to Google Classroom. So we'll have our bell work first to be followed by the presentation of our lesson. We'll have the group work, that worksheet, exit ticket, and we'll have a survey. So we have this bell work and it's shared in Google Classroom. So you can refresh your Google Classroom and do the bell work. So this is about vocabulary that would help us connect to our new unit for this year. And some of the vocabs or the words here we already learned in the past few days. All right, thanks for doing your bell work, and we'll have our objectives for the day. We will be able to solve for the following: a central angle, an inscribed angle, and its intercepted arc by using the formula and showing complete work. We have two essential questions that later we'll be able to answer because along the way we will be able to learn something about this lesson. So, what's the relationship between the central angle and intercepted arc and inscribed angle and intercepted arc? Central angle is an angle whose vertex, so the vertex is at the center of the circle. That's the reason it's called central angles because of the word center. The vertex is at the center. So the first picture here, if we take it and examine it carefully, the vertex is at the center of the circle. So that is a central angle. The second diagram, the vertex is also at the center of the circle. So that's a central angle. The third diagram, the vertex is inside the circle, but it's not at the center. So that's not a central angle. All right. Now, how are we going to measure this central angle and its arc? The measure of a central angle is equal to the measure of the intercepted arc. So with this diagram, angle 1 is the central angle. So the measure of the angle 1 is equal to the measure of its intercepted arc, the one outside, labeled K. That's the arc K. So they should be equal to each other. Let's have another example here with numbers. So angle YOZ is a central angle measuring 110 degrees. So the one in blue, that's 110 degrees. That's a central angle. The intercepted arc is on the edge of the circle that is coming from the central angle. And that should be equal to each other. That should be measuring 110 degrees. All right, now let's take more examples here. Now, what if we have this? What's the value of x, the one in red, or the measure of the angle AOB? Based from what we learned about central angles. So with that, that should be 25 degrees. Because it should be equal, right? Central angle and its intercepted arc. How about the value of z, the one in blue, or the measure of arc CD? So this is the reverse. We're measuring the arc. If the central angle is 55 degrees, so its intercepted arc should be the same. It's 55 degrees as well. Okay? Now, How about the one in between them, that y? We have to remember that the full circle measures 360 degrees and the half or semicircle is 180 degrees. So if angle COD is 55 degrees, the one in blue, and angle AOB, the one in red, is 25 degrees, what is that y? If we put them all together, that's half of the circle, so that should be 180 degrees in all. So that would be 100. Why is 100? Because we have to subtract 55 and 25 from the 180. So the y is 100 degrees. Okay? Now, on our second topic today is about inscribed angles. An inscribed angle is an angle whose vertex is on a circle. It's no longer at the center, it's on the circle, and whose sides contain chords. Okay. When we say chords, the endpoints are on the circle. Okay? At the same time here, it's inscribed when the vertex is on a circle. All right, now let's take this four diagrams. Example 1, look at that. The vertex is inside, it's not on a circle, so that's not an inscribed angle. Example 2, that is an inscribed angle. So it's inscribed, let's make it simple. All the points of the angle rather should be on the circle. Okay? Not an inscribed angle for example 3 because the vertex is at the center, so that's a central angle instead. And lastly, example 4 is an inscribed angle. Look at the points. The 3 points in the angle, it's on the circle, and the vertex is on a circle. Okay? Now, how we measure this, what the theorem states, the measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. So the measure of that angle 1 is equal to half of its intercepted arc, which is arc K. To be specific, let's take this example. So the inscribed angle here is the one in blue, the angle y something z. All right, the one in blue, measuring 55 degrees. Its intercepted arc is in red, arc yz is 110 degrees. So the measure of the inscribed angle is half of its intercepted arc. 55 is half of 110 degrees, and this is correct. All right, now let's try to evaluate this diagram. What is the value of x, the one in red? What's the measure of that angle PTQ? That's an inscribed angle. Its intercepted arc is 40 degrees, the arc PQ. So half of that, what's the half of that? That is 20 degrees. Okay? Now, how about the value of y, or the measure of RQR? So we're doing the reverse thing from what that blue example is. So inscribed angle PSR is 50 degrees, and its intercepted arc should be double, right? Because the inscribed is only half, right? So the arc PQR should be double the 50. That should be 100 degrees. But we have PQ is 40 degrees. What is QR? So 100 minus 40 is 60. So this is the work. So the Y is 60 degrees. All right. Now, let's have more of this. We have 2 more examples. What is the measure of angle SQR? QR, the one in question mark, what is the measure of that inscribed angle? If its intercepted arc is 104 degrees, so we simply take the half of that 104, and that would be 52 degrees. Okay? Last example. What is the measure of arc GH? Arc GH is the intercepted arc of the inscribed angle GFH, measuring 86 degrees. So we'll do the reverse of the first example on the left side, okay? So what would happen here? We will double, right? Or multiply by 2. So we would have 172 degrees for the measure of arc GH, because inscribed angle GFH measuring 86. So you multiply it by 2 or divide it by half, we are getting 172 degrees. All right, so let's remember this. We have central angles and inscribed angles. Remember we talked about earlier, there's a central question. What's the relationship between central angle and their intercepted arc? The central angle measurement or measure of central angle and the measure of its intercepted arc will be equal to each other. Okay? How about the relationship between the inscribed angles and its intercepted arc? Well, it says that the measure of central or inscribed angle is half of the measure of its intercepted arc. Okay? Or we do it reverse. But if we're solving for the arc, we simply multiply the angle measurement into 2. And if we want to measure the angle, then we have to divide the arc measurement into 2 instead. All right, so let's do the group worksheet. It's in Google Classroom. Let's do that one. And after that, let's do the exit ticket. All right, thank you so much and enjoy your day. Have a great day. Goodbye.